Hello! Today I am going to touch upon just a little bit on the topic on the identity and access management. But before I do so, I would like to look at the audience for a moment. Is there anybody here who considers to be an IAM expert? Anyone? Okay.
What do you mean by expert?
I have a counter question, but we have a hand here. You consider yourself to be okay. What is a phantom token?
I think it's the token that doesn't possess any information, but you just use it there's no information in it. You just you just use it to access something.
Very close. It was the OPAC token, the definition you gave for, but the phantom token is a combination of the OPAC token and GVT. Okay, we have almost an expert in the house. That's good. Who considers to be like an advanced level for IAM? So, it means this presentation will be almost for everybody. That is the good news. The IAM topic is quite vast, and I won't be able to cover everything right now, but I'll try to start at the very beginning, so that at the end of this presentation, my goal is not for you to know something or have a practical approach or on anything, but you know the keywords, you know the basic principles to go and research and do your own investigation in the area you want to go further on. Hello, my name is Jānis Lācis, I work at IF Insurance, and let's not spend that much time on me, but look at what we are going to talk on. I'm not going to give any IF information, I think that's not what I came here for, but we are quite a vast group. We have 1,400 in-house IT employees across 7-8 countries, so there's quite a big IT infrastructure to work with. So that's why we have quite somewhat evolved IAM situation. I'm going to demystify authentication and authorization. Everybody who has been in Stack Overflow or any other forums or in posts or in YouTube, people say one thing but they mean the other and the other way around. So I'll try to talk on that. Slightly discuss different ways of securing applications, just to see that there are many, and our main course for this presentation will be the global standards, OpenID Connect, and OAuth 2.0. And I'll mention some parts, I guess, interesting project from IF, how does that all of the theory come into a practical example, so this wouldn't be too theoretical. There might be a lot of information, but don't be discouraged, you'll get the hang of it. So, what is authentication and why do we need it? Well, we are in a dev club, and I would assume everybody knows the answer here, right? If all of the APIs, all the mobile applications, and all the communications would be just open, there wouldn't be any problems. Everything would be secure because everybody could access everything, right? But we work in companies, we are working with client data, we're working with our family finances, or we're working with our fantasy football league or whatever. We need a way to secure some information, and we just need to find the best approach for each scenario. So there are different ways how we can do it, but essentially we want any device, user, human or whatever, to authenticate. To see the one who is consuming us, our services, our products, we can identify that service or the human. So that's basically why do we need it. But the big difference here, the big difference here on the authentication and authorization is that the authentication is who you are. You are logging into a social network, or you're logging in anywhere you want to log in. You're basically saying you're John Doe, you have your password 123, and you're good to go. And Facebook already knows that this is for John. But authorization is what you can do. So authorization is not who you are. Authorization is what you can do. For some of you, it may be a quite self-explanatory thing, but in my years of travel, it has been proven that people really don't understand these terms. When you are logging to this mentioned Facebook, you are not seeing your mom's friends. You're not seeing your girlfriend's messages. You're not seeing your boss's pictures and be able to edit them, right? There are different kind of roles. So when you authenticate, it's just who you are. And then to the identity, to the part who you are, we attach different kind of roles and different kind of things you can do, and most importantly, what you cannot do. So that's the main difference on the authentication and authorization. About different kind of ways how to secure applications, I'll just quickly go through them. Username and password, I guess I don't need to explain that one. One-time password, something which is generated just one time, or generated and being used just one time, like a scratcher, like or anything in real life. And then it can be through an SMS, it can be through an application, it can be an email, it can be all different sorts of ways. Two-factor authentication, or 2FA, known publicly in forums, is not specifically username, password, and one-time password. It's just one of the most common use cases. But it can be any two factors. It can be your eye scan or your blood drop. Any two factors will work. The most important part is that we don't want to rely on one method. We want to combine them. If you attach your password to a sticky note on your monitor, that's not insecure, but if you have that one-time password and you are in the bathroom with your phone, people still can't log in because they need that one-time password. So it's good to combine two secure methods. Federated authentication is when we don't want to care about authentication and we just give it to somebody else, aka federate somewhere else. Bank IDs, social platforms, you name it. Biometry, quite simple, face, touch, and in the last couple of years in the industry we are already using voice recognition. It works quite well, but it's not yet recommended to be as a single method, but it can be a great additional method, especially when using, for example, a call center services. But I'll talk on that a bit more a bit later. IP restriction, I think everybody here understands that. Certificate-based, I think it's also quite clear. And then I'll talk about one interesting project very quickly at the end, SMS-based, how we solve the problem for a Nordic client using kind of all of this knowledge. Before I deep dive the main topic and the main part, I want everybody to just remind you that when you are working on a project, and you are defining your workflows, you don't just have to think about creating the user or logging in the user. You also have to remember about logging out the user. And what does that mean? When are you going to delete the users? Is the process manual? Is the process automatic? Is it a batch job? Is it scheduled? Is your boss just kicking you on the shoulder and then you're doing manually? You kind of have to define all kinds of flows so that you are prepared for many scenarios, because sometimes people are stuck in the happy path. And we don't want to be stuck just in the happy path, because when there is a long session, what happens then? When the user is inactive for 6 months, what happens then? When the user has leaked some information and you have no way to lock him out, what happens then? So define your workflows. So this was a very short introduction just to get our minds working and thinking, and I hope they are. So let's get to the main course. But before we get to the main course, we have to talk a bit of history. So it was, 17 years ago, was it? Almost a bit more. What did we have then? We didn't have an iPhone, we didn't have a smartphone. We had simple forms, logins, cookies, websites. It was very basic. We have had a very quite heavy standard called SAML. It is still being used in some big corporations, and banks are a bit afraid going away from it because migration always equals costs and time spent, and there was no mobile app login. And most importantly, and the key question I want to answer during this presentation, there was no delegated authorization. Now, what is delegated authorization? It's quite simple. How can I let a website access my data without giving my password? Sounds simple, but back then there was no solution. There was nothing. So I'll repeat it one more time because then I'm moving forward. How can I let the website access my data or subset of my data without giving my password? So So we all have seen these pictures, right? We go to Spotify, we want to listen to some music, we don't want another username and password combo to remember, and we just click Facebook, and then we give some consent that Spotify will receive name, profile picture, birthday, email address. That's great. And same thing for when Google asks to share your information with some application or website or web shop or whatever. But do you know that these are not fake screenshots? These are real screenshots. So let us walk through on the left on the Facebook. It is late 2008, you have just registered at Facebook, you have some couple of friends or colleagues as your friends, and back then people were using email contacts. It was a thing, people had email contacts. And Facebook said, hey, you want to invite all of your friends? Just give me your Google email and password, and I'll take care of the rest. How does that sound? Would you click this button today?
Now sounds very bad.
Same thing for Yelp, a place where you could, and I think still can, put some reviews. So we don't have a solution, but just give me your Google email and password, and I'll just take the contacts, or I'll just take whatever, and I'll just do everything. What is behind your Google password and Google account? Your pictures, your documents, your emails to the wife, to the mistress, to everybody. Devices.
Google Cloud.
Smart home, Google Cloud, all the backups, your life. But give me your password and I will just take the contacts. Sounds great, right? But it wasn't great and it wasn't solved. We are laughing right now because we live in a happy path society, but there was no solution back then. So what happened? All of the, not all of them, but some of the big tech giants created like a conference, like a get-together, and they came, like Google, Facebook, etc., and they said, hey, we all have the same problem. Now let's all build a solution. And that's what they did around early 2010, early 2011. Or was it 9? Doesn't matter, it was around 2010. So they decided that there is a problem, the delegated authorization problem. We have no way of just taking some subset of data. We need to take the whole password and take your whole Google backup or whatever. So they came together and created this protocol for authorization. Now when I say protocol, I have to be very specific because it's not a library, it's not a code, it's not anything practical, it's just a description. It's basically a blueprint. How should things work? And what did they design? They designed a way how to give access to the user's data without revealing their long-term credentials, or a fancy way of saying the password. So what they designed is something called access token, which we'll get into more details. So access token is a string which contains some specific information about some properties or metadata on this access. So how long does it live? What kind of access does it provide? So they designed this access. So anybody who has this token can make requests to do what is inside the token. Sounds great. But a couple of years went by, and then everybody kind of had OAuth, everybody had solved the problem with the access tokens, but then there was another problem. What about identity? What about authentication? There was no solution there. So a couple of years, like Facebook and Google, they built custom solutions, each of them, and they weren't that terrible, but they weren't great either, and they weren't standardized. That was the main problem. So again, a couple of years later, they came together and created another layer on top of the OAuth, OpenID Connect, commonly known as OIDC, which is an identity layer basing on similar concepts as does the OAuth. So, what does this allow? We can share third-party applications, users, data. And instead of using access, which is for authorization, we will use identity token, which will work in a similar fashion. So that mobile devices, or nowadays cars, or any kind of device can just share sessions and the users and everything there. But in order to understand how does this work in a more practical way, we have to get some definitions. And when I say some, I say many, but let's start with some. A token. I'm guessing and I'm assuming at least half of you knows what is a token. But for some of you who may not, I'll do a brief comparison with a real life example. Everybody has been to a hotel, right? When you go into a hotel, then you straight up go to the second floor, room 203, try to open it, it doesn't open. What the hell? So, oh, we didn't like authenticate, we didn't get the key card, right? So we go back to the receptionist and just show our identification. In Latvia, it's only ID or passport, which works. A couple of years ago, it was a driver's license, which also works. So we need to authenticate in a secure way. It is considered to be secure in our country. So we authenticate, and the hotel receptionist gives a key card. This credit card, white or whatever color key card. Now, what can we do with it? We can access our room. Great. We can access the pool between 7 and 10 o'clock. We can access the lobby during the hours the administration is on nap time. What can't we do? Can we go to the kitchen? Can we go to the administration room? Can I go to the next room, next to my room? Can I open any of these? No. So this key card contains very specific information, what we can do. We have specific things and specific lifetimes. So we are staying for the 5 days, and it ends on Friday at 12 in the middle of the day. And 12:05 we try to use the key card in our room. Does it work? No, it does not. So it combines a lot of metadata and access on what we can do with this token. And that's just a real life example. And it's quite similar to the real auth token usage. So we get a token, somebody is issuing it. Anybody can use the hotel keycard or token if you get a hold of it. So if I walk by the rooms and I see an unattended keycard, I take it. What can I do with it?
Copy.
Yes, of course, I can copy it, but what can I do with it? Sorry?
Try to open doors.
Which ones?
Any, all of them.
Any, all of them, maybe. Yeah.
Force.
So, a question to our audience. Why are the hotel key cards blank?
So no one knows which room they are.
Exactly. So nobody knows which room to open. If it would say administration, wouldn't that be crazy? You could just do anything. Issue yourself a lifetime of cards with no expire date. So yeah, quite crazy. A hotel keycard, similar as a token, can be revoked at any time, and the hotel keycard does not contain any personal information. It doesn't know you're called Peters, Jānis, or Anna. It has no information. Of course, the administration has mapped this information on their system, but if I would find my colleague's keycard or take it out of the bag, there's no information. I might guess his access, but there is no information. So it doesn't include any personal information, which is great. You can access multiple doors, similar as access token, you can access multiple resources, and it expires sometimes. It should expire, and we shouldn't have a too long of a lifetime.
Are you sure token is uploaded to the card, or each card have unique identified number which is used inside the system?
They rotate them. They don't have assigned numbers. It's not like one key card will be forever number one in their system. They do a clean swipe and then they kind of
Every time.
Are you sure every cards are readable, or only and these hash are used to be openable for some doors and is rotating inside the system?
So when a token is written there, it is kind of protected not to be overwritten by anything else. So in order, for example, they want to change my no expired token to a new member for administration stuff, they would just clean swipe it and then would overwrite with their new stuff.
It's immutable, right?
Sorry?
It's immutable.
Yeah, it's what it is. I tell you a small funny story. 15, 16 years, I was first time in London, and I was going with my schoolmates back then, and we were in this very, very small room, and there were 2 bunk beds, two stories, and it was like this big. It was literally nothing. There was no place to stand, but just 2 beds, and we could get out. And we were the 4 of us, and they gave us 2 hotel key cards. And it was the first time we saw this. We were never in a Latvian hotel, and this was the first experience. And we had 2, so that means that we kind of always, if we split in pairs, somebody always has access. And then we kind of, as teenagers opening lots of closets and seeing any free stuff or what's happening, we noticed a new card, which was inside the top of the drawer, top of the closet. But this card has a hole in it. And we're like, I don't know, what is it? We couldn't think straight, and none of us were technical. And we were like, hey, it must be a spare key card, right? Makes sense to have a spare key card inside the room for infinity time. Makes sense. So, but we go outside and take this card, and we open our doors, and it works. And now 3 of the 4 of us has a hotel key card. Isn't that great? So we're goofing around, and some days go by, and then we're going to the girls' room, and we're like, hey, wouldn't it be crazy if that wasn't a spare key card, but that was somebody from the staff who was cleaning our room and left it? And we wait for a moment when the girls don't hear us outside, and we open the door, and the girls were shocked, and it was crazy. We had a master key card. We actually did try for a very brief second to wait for the next room to the girls' room, and we opened it. It was a big room with 9 beds, all the suitcases, 9 passports, some wallets and some other valuable stuff, just plain on the table. And some teenagers just opened a room because somebody left a token unattended. How does that sound?
When did you came out?
Nice.
What?
When did you came out?
From the prison? No, we were very honest, we didn't steal anything, but I'm just trying to showcase the importance of losing a token. It is very sensitive both in real life and both in OAuth world. So, let's move on. So, let's look at some practical examples. So, John wants to listen to some music. He goes to Facebook, and now he doesn't want to remember another username password combo, so he says, hey Facebook, just you take care of it. Spotify goes to Facebook. If you haven't authenticated, you authenticate. Then there is usually for internal companies it's an optional step, but most likely for external companies it is a mandatory step, so there's a consent. They are asking, do you want to give this specific access to this application? If you say no, then end the presentation and I go home. But if you say yes, then we carry on. Facebook is redirecting back somewhere, somehow to Spotify, and then Spotify goes and gets some information. So it did get the consent to, yes, user said please take this public profile, email address, or whatever basic information, and go to some api.facebook.com or whatever service and take what you need. Now that's the gist of it. That's like being with no details. But let's get some details. So the flow I just showed was very generic. But there are multiple flows, and some are still popular, and some are still outdated, and some are legacy, and some are even dangerous nowadays. So there are a lot of flows, and I won't go through all of them because then I would have to take all 3 sessions. But what I'm going to talk about are what I would say 2 most commonly used ones, which is client credentials and authorization code plus PKCE, which is usually spoken as PKC. And how to know who is working with the application, we have to answer one question. Who is using the application? If it is a user, then we're using the authorization code flow. And if it is a machine, server to server or whatever, then we are using client credentials. But how did the Spotify get an access to that Facebook API, that Facebook service? So we have to introduce another term, scope. So when you are on your mobile device or using any kind of service, and then you want to swipe down and refresh your email feed. So what is actually happening behind your device has some specific information about who are you, who have you authenticated on your device securely, and then that you want to read mail. And let's imagine there is an API behind that. So your token, your identity contains you, and it could have configured some access, for example, like to read mail. Let's imagine there's an application that you can only read mail, but you can't send one. It's just a custom application we made for fun. So if you would go to the mail server and try to get some information, you would receive your mail because you are there as a subject and you are kind of the audience there with your phone specifically, but you can't get another mail. You can get somebody else's mail. And in this case, well, in this simple scenario, you can't also send mail. You can just read mail. So scopes help us limit access to more granular definition so that we can kind of be very least privileged about how we design things. Now, if you're talking about scopes, it would be unfair if I wouldn't mention both definitions. So there are two things to consider here. One is from auth perspective, so authorization, access, and the other one is from OIDC, so from the user perspective. From auth perspective, scope defines access. It just defines it's a space separated identifiers, and we just are going to list all the things we can access. But from the user perspective, a scope can contain grouped pieces of information we call claims, which is essentially a piece of entity some sort. So scope in auth gives access, but in OIDC contains pieces of information which are later resolved in the identity token. So why do we need that? For some applications, for example, who wants to request a profile information of some user, but don't want to specify the email, the first name, the last name, and all the different kind of properties, you could just say profile, which is a group of the basic profile information. Now this is configured on either side, usually on the authorization server side, but I'm getting ahead of myself because I haven't explained what that is. And last slide of definitions, I promise, for a couple of minutes. I will explain some of the most common definitions which are taken out of the standard. Now when I'm going to say client, I'm not going to mean human or end user. From now on, when I say client, a client is an application which is requesting the protected resource on behalf of the resource owner. So resource owner, it's just end user. It's just the user. But when you are looking at those standards, then you have to be very specific when you are referencing, because that's the terminology they use. But the definitions are kind of my own to make them more human-like. The resource server, sometimes the resource provider, is the server hosting these resources the API wants to access. So it's where your data is located. Imagine any social network application. So you, I don't know, Peter, logged in Facebook. Do you host your data? Do you host your contacts? Do you host your images or messages or clubs and everything? Or pages you've liked? You host nothing. But you own the data. You own all of the data. So in theory, you own all of the data, and you should be able to request any application, any company, anyone to remove all of it. What?
Right.
Yeah. Well, you should, because if you don't, there's some penalties, but you should be able. And that's what is the resource server and provider. You don't see, but it's being used actively. So client, again, it's the application, it's not the human. The human is the resource owner. The authorization server, the big central brain of it all. The authorization server is the one that authenticates the resource owner and issues tokens to get proper authorization, to give access or to be a broker or a proxy for identities and many other things which I won't cover here right now because we are talking about basics. And authorization grant. Sometimes it can be found on some internet blog posts as authorization flow on different kind of variations, but it essentially describes the way the communication occurs. So if we're talking about the two flows we are going to talk about, one is like server-to-server communication, and the other one is where user is involved. So it kind of is different for each communication type and has its own security characteristics. And what I have else here, so redirect URI, it is location to be redirected after we have successfully passed the consent step. So these are all the definitions. Now let's see how does that look all together. John, resource owner, we know some definitions, let's try to populate them. Still wants to listen to some music. And goes to the client, Spotify, and again doesn't want a new password combo to remember and says he wants to just use Facebook. Before we go further on, we have to take a technical break. We are going to define two variables in our memory right now. Won't be that crazy because it's just two. First one, code verifier, a random string. Right? Just a random string. And a code challenge is we are taking this random string and we are hashing it. So it's encrypted one way. So we are hashing it with some kind of method. Now let's see where that later comes into hand. So now we are creating the request with Facebook, the authorization server. But now in our request we know that we are saying that when you come back, send us to the spotify.com/callback. And when you do something, please return us a code. Well, the whole flow is built on authorization code. We'll see what it is. What is the scope we would want to see? So we want some profile and contact. So it's a group of user entities. And we are sending this code challenge. Now what was code challenge? It was the hashed version of the random string. So let's see what happens further on. So Facebook is still going to the consent, saying, do you want to allow access to this data? If you say no, the flow breaks, but we are moving forward. Now, we are being redirected back to the place we defined earlier on. And why is it important? Anybody? Why is it important to specify at the beginning of the request where to send back?
Because that's where you will be handling the information that you get from the authorization server.
Yes, because if you would just send to some random location or to the same one, each endpoint is like designed to do some specific things. And this endpoint was designed to receive the authorization code. So when we are doing all of this, this all is actually happening on the browser level. So this is front channel communication. And as I would assume all know, it's not secure. So now with the authorization code, we would like to make some backend communication calls, make it a bit more secure. So what we are doing, we are exchanging the authorization code we just received on browser level, and we want to exchange it in a combination with code verifier. So that was the initial random string value. We want to exchange it for access token. So since this is back channel communication, it's much more safe. So when anybody would get this authorization code, it means nothing. It's just a random string to anybody who doesn't know what he's looking at. And there is no information inside. But when you get the access token, now that is the real value. Now that has to be stored securely. That has to be stored like you don't want to open another girl's room. Or you want to open it and then you want to try to steal it. So we have the access token, and then using this access token, we can proceed to the resource server and take the data we want. So this is how to combine all of the terms and definitions and make it in a practical way.
Question.
Yes?
In the scope, the user asks for the profile contacts.
Yes.
But then in consent, there is no contact, but only
yes,
public
it's just a screenshot thing, or well, I made it a GIF. It's a very good catch because it's very correct. Yeah, it could be like comma contacts, or but that's an interesting point because the request contains it, but if the consent step doesn't write about it, you don't know about, but you don't know about it. So that is also a very careful thing to make sure what is happening. Because sometimes you get a notification, or you gave like a report afterwards. Oh, you gave this application this access, and then maybe there's different information. So that's a very good catch. But yes, there should be comma contacts. And to be more precise, the request with the scope, those two are for OIDC, so for the identity layer. But we should add like user.read scope, so that we can have the authorization scope to use when you're going to the research server and getting the access, to be more precise. So it's like 2 adjustments there. But that's like the big picture stuff overall. Okay, client credentials flow. Now it will be much more simpler. Because it's a machine-to-machine communication, there is no browser level, nothing happens to our visible eye. So there is a client, and then the client already has made an arrangement with the authorization server, and they have aligned with a client ID and a client secret. You can just think of it as a machine-to-machine username and password, but it's just called client ID and secret. And to be more precise, in the previous slide, there is also a client ID and client secret combination. And actually, there is a lot more things I'm not mentioning right now because I want for you to remember some of this, so not to overflow the presentation. So they have aligned with client ID and client secret combination, and they have scope create account. And they're saying that the response type is client credentials, so you'll already get the token. And with the token, let's say there is some application who has their like internal users, and then they're hosting their own Facebook instance and wants to create a bunch of company users or whatever scenario. They get the access token, and then they get the data or get the access to do something, create something, and that is basically the client credentials flow. Much more secure, much more simple, and not that much to talk about in introductory presentation. We have talked about tokens. What actually is a token for those of you who haven't seen it? So a token, it could be in different formats, but nowadays it's mostly as a JSON web token, commonly pronounced as JWT, JWT. And it's basically there are 3 parts of the token, and there are some technical data, and then there is the payload. Of course, we get all the information: who issued the token, when does it expire, what's the client, what's the scope, and so on. And of course, the token is kind of signed that nobody who intercepts the token can change anything, because if you change anything, then the signature won't work. So it's a thing they have kind of agreed before how it is inside, and that the signing part is done by the authorization server. So tokens contain some specific information so that you can go and access. And the authorization server has the information on all of the scopes, all of the things. It's like basically a big configuration brain, secure configuration brain. Then a thing we didn't talk before is a refresh token, which is actually provided and given to us from authorization server when we get the access token or the identity token. So a refresh token doesn't contain any valuable information, nor access, nor identity, but it helps us to have a seamless way for the user experience to refresh the session. So that all the important tokens like the identity token or access token, they shouldn't have long lifetimes. They should be, when they are used, they're being taken, it should be like, I don't know, 5 minutes, sometimes for specific scenarios, maybe hour, maybe sometimes a day, but nothing more. But imagine some scenarios where you don't re-authenticate, but you are always on, right? But it doesn't mean your information is being shared, it's just the refresh token who has a very long lifetime. And if that is stolen, there's no security breach, basically. And then that token can reissue an access token. So the refresh token has the opportunity to get new access tokens from the authorization server. So it's basically helping to shorten the meaningful token lifetime. And the identity token, very similar to the OAuth token, is just containing some pieces of information in the same JWT format. So you can see name, given name, family name, birth date, email, picture, and whatever you want. Yeah. One thing I want to mention, a caution for any people who want, oh, I'll go home and I'll find some flows and start developing. And some people, unfortunately, still use this something called an implicit flow. Implicit flow was very popular many years ago. It was basically everything people used 10 years ago. But 10 years ago, browsers didn't have such JavaScript and other web capabilities as it does right now. The access you give to your extensions in Google or elsewhere have very much a lot of information and they can read everything which is happening on your browser level. And what happened in implicit flow, instead of returning the access token securely, it was returned directly back to browser. So if you find an application, well, I'm not going to teach you, but if you find an application and you know it's implicit flow, F12, click, and you have an access token. So don't use implicit flow. What you should use a pattern called as BFF, which is backend for frontend, which is more commonly used for some single page applications where you kind of like React or whatever, and then you create this, you could say, artificial backend, so to make the secure calls and to store the tokens on the backend level. So that's why you shouldn't use implicit flow, and that's one solution you should use for the single page applications. And then I'll very quickly, it will be very short, go over how does a big team working with identity and access management solutions look like. So we have a lot of solutions we are covering. We are configuring and having this authorization server called Purity, which covers this auth and OIDC client configuration. We have extra functionality for username and password accounts. We broker some authentication via some Signica Telia brokers, so that we provide bank IDs for all of the if serving countries. So there are different banks in Finland, different banks in Sweden, and all of them have some specifics which all have to be configured for the applications to be used on. And one of the things I will explain, a classic one example where it was quite bad many years ago, and a project called identity verification. So it was, what was it, 5 years ago? The scenario was like this. It was in Norway call center, and you would call some call center and saying, oh, my car broke, or I need something, and you're saying, who are you? Oh, I'm Peter, of course. And they're like, okay, that's it. That was literally the authentication they had. So now we try to improve this process, and we are adding now a layer of voice authentication as well. So what happens, it's quite cool when you call the call center. Of course we do the bank ID approach, which I'll explain in a second, but when you call the call center, and then the voice authentication, it needs only a couple of seconds, like 3 seconds, to authenticate the user, and gives a percentage of how much it's probable that this person is actually Peter. And it happens seamlessly in the background, yes.
How you get the baseline to compare with?
It's the first time you have to onboard, which is like 5 seconds. You do it once, and then it's like
in some on presence, on some
on the phone call. On the phone call. On the phone call. Yeah, on the phone call. But still, what's happening on the bank ID part is that we are sending the call center is reaching out to our service, and we are sending a localized SMS, and you kind of know that you're like from Finland, and there are some screenshots of Finland banks. You authenticate on your phone, and the call center all the time is pinging and looking at the application. Has the user authenticated? And it has, so everything is successful, and then it's all good. Yes?
Just a question regarding the voice authentication.
Yeah.
How do you deal with, like, did you have any like deep fake?
They actually work quite well, and they are saying they already detect that this is a pre-recorded voice.
Okay.
Of course, it's just another factor. It's not solely what we trust on.
It's just one of them.
It's another factor just to improve the customer experience.
Okay.
Yeah. And yeah, a couple of years ago, I'll wrap up already. A couple of years ago, we had this idea to use Purity, the authorization server, as a big central point for all the partners and all the applications who want to use if services. You're going to book a travel, and then somebody says, oh, you want to buy insurance, and you say yes, click, and you don't know the magic happening behind it because it's an integration with some kind of insurance services, similar to a car shop, car repair shop, etc. And the overall big picture, when you have a lot of people and you are serving more than 20 million unique logins per year, and serving more than four unique million users, the logistics and everything is quite crazy, and you need a lot of people to serve all of this. So, to wrap up, there is a lot of things I didn't tell you today, because I just wanted to start from the zero and to get somewhere, and I hope you remembered some of it. You can't know everything, but you can plan, and you can try to mitigate some risks, because nowadays those identity-related issues are quite costly. So,
what about GDPR in your system?
in the previous one?
Yeah.
Well, there are some metrics we can talk a bit afterwards, but no, it's GDPR compliant, and
Compliant, they don't have any
it's-
penalties?
no. But it's very different from country to country. So all the 4 Nordic countries, they have one thing, and then Latvia have a different kind of thing.
Not a common European
No,
police?
it is, but there are some kind of connection with some specifics, like using a bank ID here, and there are some just small details here and there. Overall, of course, it's a Europe regulation. And yeah, to avoid surprise, you should authorize. Thank you. Any questions?
Just to clarify, like even before 2007, there were options where you could do these integrations with sharing some auth information. There was just no standard. However,
Yeah, that's
all
the.
the public key infrastructure was available long ago.
No. Of course, the whole idea there was no centralized, as they meant the OIDC, the identity layer. A couple of years without it, and they understand, no, we need something centralized because there are known issues. But if we are each walking our own path, then you kind of get into problems. Yeah.
Banking did it.
They used SAML, and it's a quite heavy standard. You shouldn't start your application with SAML now.
What do you think the most secure way of authentication for now? For client?
The trend and what I follow is to get rid of passwords. So non-passwordless is what I would say, non-password approach. So there shouldn't be this. It's not yet popular in Latvia.
Some passkeys?
Yes. There are passkeys is one thing we are kind of working on and already implementing in some countries. The most common services and like what we see in everyday life, we don't see that much, but going away from passwords is something we'll see more in the upcoming years.
What about hardware tokens?
But that's a bit different topic. YubiKeys and all that other jazz. That's a whole different story. Yeah.
Can you explain me why passkey is better? Because previously people used like 2-factor authentication, so it's the password, a username, and the second factor, and the passkey is only 1 factor. Why it's better?
It's hard to understand because we don't have that culture yet in place. So there are just some somewhat theoretical things, but because of the leaks, because of the user habits, I would say. Repeating passwords, using simple passwords, making us more easier to hack it. I'm not saying the password with another factor works bad. It works kind of great, but the user habits are on some uneducated skills. Yeah.
Maybe because you have to store this passkey with some special tool.
It's usually your mobile phone. Everybody
Yeah,
kind
I
of
can give
those.
a little bit. Not always passkey is passwordless. It's in many cases it's a second factor.
Yeah,
Yes.
a bit changing.
Yeah,
Because
you can allow it or disallow passwordless,
Yeah.
and passkeys and also some kind of encrypted on your device. Or
Yes.
What type of authentication would you suggest for IoT devices? Should we use OpenID and OAuth?
There is a specific flow. It's called device code.
Oh yeah.
It's for users. We, for example, use it in cars. In what country was it? In Sweden, when you drive out of a Volvo center, and then you have this panel, and there's if insurance, and you just click it or submit the claim or something, and then it's inside your password. And then there is the device code. There are other flows which I mentioned, but I just covered 2 of them today.
Specific one. Okay.
One-time password is not secure anymore.
It is, but it's just one-time password. It works with a combination of other factors. Yeah, it's okay. Yeah, it depends how it's delivered. It can be delivered insecurely. Yeah.
Do you use OpenID for first party for your own systems as well?
No, then we use client credentials mostly, and we just
No, I mean for securing your own applications.
internally.
Yeah, first-party.
Then it's a combination of network stuff, IP stuff. We have some internal gateways, and it's like a combination of a lot of things. And mostly they kind of resolve. Yes, it's both OIDC, client credentials and authorization code flow, but it depends on the scenario. But it's never just alone. It's usually a specific VNet or a specific other thing. Yeah, it depends. Is it like in what kind of pool of applications it is? It varies. Yeah.
I mean, I'm just asking because like a lot of people use OpenID also when there's the trust is not needed, when there's within the same company, you know, and you don't need the consent even because, you know, all the apps are kind of...
Yeah, we don't have consent internally. We are working on it, but yeah.
Yeah. Do you feel that it also gives like too much of the overhead? I mean, something that is too much overhead for OpenID for first-party scenarios. That you need to like single sign-on for instance is more complicated. Like what else? Like these refresh tokens. Like you need to like log out all the sessions if you use refresh. You know, a lot of edge cases.
Yeah.
So,
it is hard because it's very easy for a developer to forget some endpoint is left open, and then it's like sometimes it's over security, but that's what lets us sleep at night. Yeah.
Okay, if you have any more questions, please.
Thank you.